All right, so section 11.6 deals with something called conditional probability. Okay, so let's take a look here. It says conditional probability. In general, the probability of an event E2 occurring given that an event E1 has happened or will happen is called conditional probability. And we say the probability of E2 given E1. This is sort of how we write it, okay? So the first problem here says a single card is selected from a deck of cards. Determine the probability that it is club given that it's black. Okay, so we're trying to figure out what's the probability that we're going to get a club given that we have a black card. All right, so it says we're given a black card. Okay, so guys, I'm going to grab my deck of cards right here. Okay, so remember we have 52 cards. Well, out of those 52, 26 of them are in fact black cards. So 26 are black cards. Out of those 26 black cards, 13 of them, the top row, are all clubs. So 13 out of 26, which is the same as 1/2. Okay. All right, let me scroll down to the next piece over here. And it says a family has 2 children. Assuming that boys and girls are equally likely, determine the probability that the family has 2 girls. Okay, so I'm going to go ahead and draw a tree diagram, kind of like the way we did in one of the other sections. So the first child can either be a boy or a girl, and the second child can either be a boy or a girl. Okay. So if I look at my sample space, we could have a boy and then another boy. We could have a boy and then a girl. We could have a girl and then a boy, or we could have 2 girls, right? Okay, so part A says find the probability that we're going to have 2 girls, okay? So remember my sample space here, we have a total of 4 of them. And how many have 2 girls? Just 1, right? All right, now part B says what's the probability that we're going to have 2 girls if you know that at least one of the children is a girl? Okay, if we're going to have at least one of the children being a girl, these are the ones that have at least one of the children being a girl, right? We either have the second one being a girl, the first one being a girl, or they're both a girl, okay? So my sample space here is going to be 3, and we still want to get 2 girls, so that would be 1 out of 3. Okay. And then part C says 2 girls given that the older child is a girl. So what they mean by the older child is the first child is a girl. Okay. So look at my sample space now. Now I only have 2 of them. The probability of getting 2 girls would be 1 out of the 2, given that the older child, which is the first child, is a girl, okay? Let me scroll down, okay? So again, conditional probability. Let's see if we can figure this out here. I'm going to kind of go through my problems that I have for this particular example, okay? So it says 250 patients who had knee, hip, or heart surgery were asked whether they were satisfied or dissatisfied regarding the results of their surgery. The responses are given in the table below. Okay, so the question says, if one person from the 250 surveyed is selected at random, determine the probability that the person, part A, says, well, that they were satisfied with the results of the surgery. Okay, so part A, we're looking for the probability that they were satisfied. So we know we had a total of 250 people who had surgery, and it looks like a total of 210 of them were satisfied with that surgery. Okay, we can go ahead and reduce our fraction, divide them both by 10, and that gives us 21 out of 25. Okay, and I don't think we can reduce that anymore, so we'll stop right there. Okay, now let's take a look at part B. Part B says, what's the probability that the person of the results was satisfied given that the person had knee surgery? So we're looking for the probability that they were satisfied given that they had knee surgery. So what I'm going to do here is, because we're looking for the number of satisfied given that they had knee surgery. So what I want to do is I want to say, okay, how many people in total had knee surgery? Well, we had a total of 95. Out of those 95, how many were actually satisfied? 75 of them, okay? If we divide both of them by 5, this should be something like 15. And let's see, what's 95 divided by 5? What's that, 19? And we'll have to stop right there. We cannot reduce that any further. Okay. All right, now let's take a look at part C. Part C says, what's the probability that they were dissatisfied with results given that they had hip surgery? So now we're looking for the probability that they were dissatisfied given that they had hip surgery. So again, what we're going to do here is we're going to look at the hip surgery. Here's my hip surgery. We had a total of 105 of those. And out of those 105, the ones that were dissatisfied were 15 of them. Okay. And let's see, we divide them both by 5. Let's see, 5 goes into 15 3 times. 5 goes into 105, 21. We can divide them both by 3. So 1/7, right? Okay, good. All right, so let me clean that up. And then let's do part D. It says, what's the probability that the person had heart surgery given that they were dissatisfied? So what we're going to do is now we're going to look at the column of dissatisfied. Okay, so we're saying, what's the probability that they had heart surgery given that they were dissatisfied? Okay, so we had a total of 40 dissatisfied. And out of those 40, the ones that had heart surgery were 5 of them. And then when I reduce that, that's just going to give me 1/8. Okay. All right. So I hope this is kind of making sense as we're going through it. Let's do a couple more again just to make sure that we are on the right track. Okay, so it says in exercises 11 through 16, considering the following figures. Okay, so we have a yellow circle with the number 1, a red triangle with 2, blue square with 3, red square with 4, yellow circle with 5, blue triangle with 6, and a red circle with 7. It says, assume that one number from 1 to 7 is equally likely to be selected at random. Each number corresponds to one of the 7 figures. Determine the probability of selecting a circle given that we have an odd number. Okay, so for number 11, we're trying to find what's the probability that we're going to get a circle given that the number we have is odd. Okay, so the first thing we're going to do is we're going to say, look, let's get all the odd numbers. How many odd numbers do we have? Well, I underlined them. There were 4 of them. Okay, out of those 4 that we underlined, how many of them happen to be a circle? Well, 1, 2, and 3. So 3 out of 4, okay? Let's try to do the same thing for number 12, okay? It says, what's the probability that we're going to get a triangle given that the number is greater than or equal to 5 is selected? So the number we're going to pick is going to be greater than or equal to 5, okay? So let's do this. Let's clean this mess up, okay? So we're going to say, okay, how many numbers do we have greater than or equal to 5? We have 3 of them, okay? Out of those 3, how many of them are a triangle? Only 1 of them, okay? The number 6. Okay, so I'm going to try 13. What's the probability that we're going to get an odd number given that a circle is selected? Okay, so first thing we're saying, we're going to select a circle. Okay, so the probability that we have an odd number given that we have a circle, okay, so circles, we have 3 of them, okay, out of those 3 circles, how many of them are odd numbers? Well, it looks like all 3 of them are odd numbers, so that should just give us 1. Okay. And let's try number 14. Okay, let me clean up that. Okay, 14 says, what's the probability that we're going to get a number that is greater than or equal to 5, given that we have a triangle. Okay, so I'm going to underline all my triangles. Okay, all right, so how many triangles do we have? We have 2 of them. Out of those triangles, how many of them are greater than or equal to 5? Just the number 6, just one of them, right? And number 15 says, what's the probability that we're going to get a circle or a square given that a number that is less than 4 is selected? Okay. So first off, we want to find numbers that are less than 4. Well, these numbers right here are less than 4. Okay, so we have 3 numbers that are less than 4. Now, out of those 3, how many of them happen to be a circle or a square? Well, the first one and the last one, so 2 out of 3, right? And then finally, number 16 says, what's the probability that we're going to get a triangle given that we have an odd number selected? Okay, so let's figure out odd numbers. That one, that one, that one, and that one. Okay, so we have 4 odd numbers. Out of those 4 odd numbers, how many of them happen to be triangles? The first one's a circle, second one is a square, third one's a circle, last one's a circle. None of them are. So the probability here would be 0. Okay. Good. Let me keep kind of moving along here. And let's see what we have. Taste test. It says in exercises 35 through 40, use the results of a coffee test given at a local mall. Okay, so it looks like we have a total of 225. Okay, so let's try number 35. Number 35 says they prefer John's Famous Coffee. Okay, so out of the 225 people that were surveyed, how many of them prefer John's? 115. Okay, so I bet we can divide them at least both by 5. Let me grab my calculator here, turn it on. 115 divided by 5 is 23. And then 225 divided by 5 is 45. And I have to stop right there. I can't reduce anymore. So now let's try number 36. What's the probability that the person selected is a woman? Okay. So again, we have a total of 225 that we surveyed. Out of those 225, how many of them are women? Well, 125, right? So guys, from here, I actually think we can divide them probably both by 25. Okay, so 25 goes into 125 3 times. 25 into 225 should be something like 9 times. And then we can divide them both by 3, so 1/3. Okay. Let me see. Let me make sure I just did that right, guys. Hold on. So let's see. 225 divided by 5. Oh, I'm sorry. 225. Sorry. Divided by 25, not 5. Was 9. Okay. 125 divided by 25 was 5. Why did I put a 3? That didn't seem right. Okay. Oops. 5. And so it stays 5/9, right? Sorry about that, guys. There we go. Okay, so now number 37. Let's try 37. What's the probability that a person prefers John's coffee given that a man was selected? Okay, so we're looking for the probability that they like John's given that a man was selected. Okay, so let's take a look here. How many men did we survey? Well, we surveyed 100 of them. Out of those 100 men, how many of them like John's Famous Coffee? 40 of them. Okay, so let's go ahead and reduce that. It's going to give me 4 over 10. Divide them both by 2. And we come up with 2/5. Okay. 38. So 38 now says, what's the probability that they prefer Manhattans given that a woman was selected. Okay, so given that a woman was selected. So again, we had a total of 125 women, and out of those 125 women, 50 of them preferred Manhattan's coffee. Okay, let's divide them both by 5. So 5 goes into 50 10 times, 5 goes in here 25 times. Divide them both by 5 again, 2 over 5. Okay, 39. Okay, so 39 says the probability that we're going to have a man given that the person likes Manhattans. Okay. So again, how many like Manhattans? 110. And out of those 110, 60 of them happen to be men. So divide them both by 10 and we get 6 over 11. And I think we got one more for number 40. So number 40 says, what's the probability that we're going to have a woman, given that they like John's Famous Coffee? Okay, so John's Famous Coffee, again, we had a total of 115, and 75 of those were women. And so if we divide them both by 5, that should be 15 here. 5 goes into this 23 times. And we got to stop right there, okay? Can't reduce any further. Let's see. Okay, that was 11.6, guys.